Hi, students. I just wanted to share with you a more simple, intuitive way to understand the solo model. So let me try to do that here. It's very difficult to write on the whiteboard here. So suppose you start a business. This is what you expect your income and your investment to be on the y-axis. Excuse me. This is what happens over time on the x-axis. You start out with a small investment, and let's say you open a gas station on a corner, and there's no other gas stations around, so you have no competition. You grow very rapidly, but then another gas station opens up on the next corner. It cuts your growth by 50%, so now you're growing half as rapidly. Then another gas station on the third corner cuts your growth in half again, and then on the fourth corner, you stop growing altogether. So this investment that you make is going to be some percentage S of your income, Y. So let's say you make $100,000, you save 10% of it. 10% of 100,000 is $10,000 you're investing. And let's say your income is twice that. So it's going to follow the same curve. Your income is going to be some percentage of your investment. So it's going to be some percentage, some function of your capital, which is saying the same as your cumulative investment, some function of your capital. So let's say your income is 2 times your capital. So your investment in your capital for the first year was 10% of 100,000 is 10,000. So your income the next year is going to be 2 times your capital. 2 times 10,000 is $20,000. So that's how this grows, and then you start to slow down due to competition as your economy or your company or your country gets older and there's more competition. Okay, so what's next is your equipment starts to get old, and it's based on your cumulative capital. Your equipment will get old, and let's say it gets old very slowly. This is your depreciation of your rate of your capital is going to be your depreciation, or how much your investment loses value. So let's say this is 20% a year times 10,000 the first year, 20,000 the second year, let's say 30,000 the third year. So it just keeps going up and up in a straight line. Eventually you hit the point where if you try to invest more, you're going to lose money because your expense of the additional machines wearing out will be greater than any benefit from the machine, since your benefits have petered out. We call that the steady state, and it means that advanced economies stop growing. While you're growing, you're in a transition to a higher stage, so we call that transitional dynamics. Dynamic just means movement. So let me spell that out. Here, your investment is higher than your costs, and so you continue to add to your investment because you're continuing to grow. We call it transitional dynamics. Once you have a loss, you don't want to continue to grow anymore. So you invest less until you're back at break even. So you're going to keep investing until you break even. That's a solo model in a nutshell. In the solo model, we invest until we stop growing, and then we don't invest anymore. We just keep making that income because it's good to make income, even if it's flat. The next thing I want to look at is how do we explain companies continue to grow? Well, we have the Romer model. That's really hard to write. And there we say that once a company reaches its limit of growth based on capital, then they can replace it with human capital or new ideas like iPhone 1, iPhone 2, iPhone 3. And the new ideas will be new products that people will want to buy, and your growth will start up again. And then you come with another new product, your growth will start up again. The way we express that is in the solo model. We say income is a function of efficiency times how many wages you pay your laborers times what return or money you make on your capital. So in other words, this is what you put in. This is how good you are at it. And then this is what you get out. So if you put in 50,000 of labor costs, 5 workers at 10,000 each, and 50,000 of capital costs, which is 500,000 at 10% interest. That's going to be $100,000. And if you make twice the amount, based on how efficient you are, you have 100,000 you put in inputs, times 2, you make 200,000 income out of it. This is an equation that's used in the solo model, which you're not responsible for in this class, named after 2 economists, Cobb and Douglas. This is how income actually gets made with an S. In the Romer model, what we say, and sorry, this is going to be to the A power in Greek, and this is going to be to the B power in Greek. In the Romer model, we add, all you need to know is that we're just adding one more K. I'm going to leave out the wage and the rate prices here. To make it easier. So this is the same as this. I just left out the prices, wages, and interest rates. And in this model, it's this times this times this times the human capital, brain power that you put in. And that's a renewable resource because you can always come up with new ideas. Your machines can depreciate away to 0 value, but you can always come up with new ideas and new machines and keep growing after the steady state by new ideas and new technology. That's how the US and Western countries grow now, because they hit the steady state mostly in the 70s, except for Japan, it was in 1990. They mostly were growing in the up to steady state over 30 years. Since the end of World War II, all the Western countries became big. But you can keep growing by this new factor, K to the B, in the Romer model. That's all you need to know for that. So hopefully you can remember that for your test. Okay, that's it for today. Thanks for listening.